Hello and welcome back to Breadboard Robotics. I'm picking up where I left off on part 1 of the series, where I 3D printed a two-wheeled replica robot of the drone from Rainbow Six Siege. If you would like to check out part 1 of this series, please see the link below. I met most of my goals with the first iteration of this robot, such as the changing LED colors, working live camera, and of course remote controllability. But there was still a end goal that I knew I would need to incorporate into my final version. Of course, this is the ability for the robot to actually be dropped or thrown without any damage to the robot or hindrance to its performance. This ended up being easier said than done, and I implemented a few different design choices to achieve this goal. Let's get started. I reprinted the hull of the robot from black PETG filament. This was to make the hull more durable and also allow for some hardware changes. I figured the old hobby geared DC motors I used in part 1 version would be too flimsy for continuous impacts. These larger geared DC motors should be more durable and also much quieter, but of course are heavier and larger. All I am doing here is soldering the output wires from the motor driver to the DC motor. The internal components of this version are exactly the same as in my part 1 video, so again, please check that out if you want to see what all of the electronics do. You can see here that the controls and new motors are working properly and in the same way as in part 1 of this series. The motors are being powered by a DRV8833H bridge, which is supplied by an 11.1 volt light bulb battery. My first idea was to create thin tires for firm flexible TPU filament, and then attach them to a springy suspension system to absorb most of the shock. The suspension system is comprised of a flange and tire rim, held taut with regular rubber bands. I actually really liked my design, but as you will see, tests concluded that the hull would receive too much trauma and then end up breaking. You can see here my first throw test ended in the breaking of the robot. The stress on the flange and rim piece was too high and led to it completely breaking off.
That's not good.
It is also evident that the tail piece broke off as well. I reprinted the pieces with a higher wall count and layer infill percentage in order to make them more durable. The first test appears to go well, but after taking a closer look, it is apparent that the robot has cracked. The new robot lower hull was modified with thicker motor mount areas to make it more durable.
Oh, something definitely broke there.
I figured that perhaps the way I designed the two pieces of the suspension was not allowing enough movement to fully absorb the shock. So I designed a very minimalist version where the tire rim actually fully suspends the motor output flange. This ended up being a total mistake, as the extra axes of rotation created by its freehanding design allowed too much movement and unacceptable loss of control when trying to drive the robot. But it did look really cool with the slow motion dropping tests. My last try to save the rubber bands idea was to up the rubber band count to 5 for each wheel instead of 4. This did appear to work better than the 4 rubber bands, but it was still not where I wanted to be. At this point, I was pretty done with the whole rubber band suspension idea. I decided instead to just throw this idea out altogether and instead create a thicker TPU tire that would not need a mechanical suspension. I also took the time to redesign the hull to hold carbon fiber rods and adjusted my infill settings for the motor mount areas to be way more thick. I was tired of the constant reprints from broken holes and was trying to make this version as durable as possible at the expense of initial print time. Let me just show you the results. This design was it. The impacts were not causing any hole damage and the drops themselves were actually much quieter. These tires were doing an extraordinary job absorbing the shocks. It looks like the flange broke here. A new thicker one should fix this right up. Thank you for watching this far. I didn't dive too much into the hardware, but please check out part 1 for this and the coding that made this robot possible. Now, please enjoy my ending showcase of the finished robot. Thank you for watching. If you enjoyed, please leave a like. And if you want to see uploads on future projects of mine, please hit the subscribe button.